Hey guys, so today we're going to review over the second half of our circles unit, and on Friday we'll have a test going over all of this. So like we always do, I'm going to do the example column, which is all the odd numbers, and the evens are going to be for you guys to practice on your own. So let's start by looking at number 1. It says determine if AB is tangent to circle C. So if, right? So it's a yes or no question. We're not sure if it's tangent yet. So AB, if you look at the figure, is this segment right here. Where it's touching the circle, what we need to figure out is this angle here, is it a right angle? So we're not 100% sure, that's what we need to check. So if it's a right triangle, I should be able to perform the Pythagorean theorem and for it to be true. So we need all three sides. So we have 12 for the hypotenuse. We have 7.2 for this side. But be careful with this third side. 4.8 is only the halfway. That's the radius of the circle. So this would also be 4.8, which means that this entire side altogether is 9.6. So when you're doing your testing, we're going to do 9.6 squared plus 7.2 squared. We want to know if that is equal to, so I'm going to put a question mark, 12 squared. So this would have been the hypotenuse if that was a right angle. So let's check this. So I'm going to type that entire left side into the calculator. 9.6 squared plus 7.2 squared. And I get 144. And then 12 squared, if you put that in the calculator, is also 144. So since these are equal, then we can say yes, AB is tangent to circle C. But the answer is yes, and then this is the reason why, because 144 equals 144. Okay, let's move on to number 3. So it says, assume the segment that appears to be tangent is tangent. Find x. So this time there's no if. We know for sure that the piece that looks like it's tangent, so the piece that's touching the circle, it is for sure tangent. So that means that this angle is for sure a right angle. So we can use the Pythagorean theorem again to fill this in. Remember that across from your right angle, that's always the hypotenuse. So this is going to be the hypotenuse. But again, be very careful with this because that 11 is only referring to this part out here. If it was the entire side, they would have given us one of these little things here. So we're going to have to figure out what this piece is first. So anytime you go center to edge, that is a radius. Well, look at this one. That is center to edge. That is radius. So this piece must be 8, which means that entire length is 19. So now let's set up our Pythagorean theorem. 8 squared plus x squared equals 19 squared. I know that 8 squared is 64, so I'm going to go ahead and write that in. And then 19 squared, let me put this into the calculator really quick, gets me 361. I'm going to subtract 64 from both sides, which gives me 297. So x squared equals 297. And then now we're going to square roots, which gets me that x is equal to 17.2. Okay, let's move on to the next one. Number 5, find the perimeter of triangle triangle PQR. So PQR. So we need to know the length of all three sides. we know that this side, PQ, is 27.4, but the other two sides take a little bit of work. So I'm going to start at vertex R. Both pieces that are touching vertex R have to be the exact same length. So since the one on the bottom is 12.2, that means that this one is also 12.2. Okay, then if I look at vertex Q, which is the one on the top, the two pieces coming out of vertex Q also have to be the same length, which means that this part on the left is 5.9. Okay, and then that last vertex, vertex P, both of those pieces have to be the same. Right now, I don't know the length of this, but we can find that because the total has to be 27. Let's subtract the 5.9. 27.4 minus 5.9 gives me 21.5. And if that's 21.5, so is this one. So now if I want to find perimeter, we're just going to add all of those pieces up. So even though it's just 3 sides for this triangle, we're actually adding 6 pieces. So we have 5.9 plus another 5.9, 12.2 plus another 12.2, and then 21.5 plus another 21.5. So we're going to add all of these up. Okay, and if I'm doing my math right, I think that is 79.2. So perimeter of triangle PQR is equal to 79.2. Okay, let's move to number 7. So on this one, we have our circle. They want us to find these two angle measurements. So when you're finding angle measurements with intersecting lines, there is 3 cases. On this one, our intersection is inside of the circle. Inside. So when it is inside, you find the 2 arcs that are created by these intersecting lines and take the average of them. So for AED, which is this angle here, that's how we're going to find it. So measure of angle AED, that's going to be 1/2 of 92 plus 140. So I'm going to put this in the calculator. And I get 116. So that first blank, that angle is 116. Okay, but then now they also want me to find the measure of angle DEC. So DEC. Now they want this angle. I'm going to use a different color. They want this part. So if I knew these arcs, then I could do the same formula, but I don't. It's actually a lot easier than the previous one, because this right here, AC, is a straight line. Straight lines need to equal 180. So in order to find the measure of angle DEC, it's just going to be 180 minus 116. Which gets me 64. Okay, and that is it for that one. Okay, number 9. Oh, I put a random J. Pretend that wasn't there. They want us to find the measure of angle KLM. So here's KLM. So this angle right here. So it's still two intersecting lines, but this time the intersection's on the outside. So the rule is similar, but not exactly the same. I still need these two arcs, but this time instead of adding, we're going to subtract. So the measure of angle KLM is equal to 1/2, parentheses, of 125 minus 51. So this time we subtract. Okay, and I am getting 37 degrees. Okay, let's continue on. So number 11, now we want to find missing value. So here's our x. X represents this portion of the line. So again, when you're finding segment lengths with intersecting lines, there's three cases. So this one, or types. This one is a type 1 because the intersection is inside. So I'm just going to write inside. So the rule here is you take two pieces of the same line. So this is all one giant line. You multiply them. So 27 times x. And that has to equal the product of the two pieces of the other line. So 30 and 18. We're going to multiply those. Okay, so I still have 27x, but let me find 30 times 18 for us. That gives me 540. Okay, let's divide by 27. And now I just get that x is 20. The next one, so again, we're finding a segment length. Now that x is that part of the line. This is intersecting outside of the circle, but even more importantly, one of the lines only touches the circle at one point, so that makes it a tangent. The other line touches the circle at 2 points, making it a secant. So this is a type 3 kind of problem. So you get your tangent, the one that touches only once, and square it. So 18 squared equals the product of the piece outside, so that's 12, times the length of the entire line. So I would need to know how long this entire line is. So I know this piece is 12, and this piece, even though I don't know what it is, it's measured as an x. So when we find lines like this, we just need to add up the pieces, right? So same thing here. It's just going to be x plus 12. So I need to multiply over here by x plus 12. Okay, 18 squared gives me 324. Okay, and then we're going to distribute. So 12x plus 144. Let me subtract 144 from both sides. And now I get 180 equals 12x. And then last step is to divide by 12, which gives me 15. Okay, and I just want to point out that these last two that we just did, 11 and 13, we were finding the length of a segment, so that is one formula. but the previous two, we were finding angle measures. So that's going to be a different formula. So make sure you're looking at the correct formulas in your notes. Okay, and we have 3 more problems here. So let's look at number 15. Write the equation of the circle that's graphed below. So when we're writing equations, we need 2 things. We need to know where the center is at, and we need to know the radius. So center, on this review, we actually have the point already there. I think on your test, the point is not there, so you're just going to have to kind of eyeball it. But that center is at -3, +2. Then our radius, so I'm going to do a line on the left side here. You just count how many squares it takes to get to the edge. 1, 2, 3, 4. So radius is 4. Now, our formula for a circle, so I'm just going to write the formula right now, is x minus h squared plus y minus k squared equals r squared. HK is the center. So you're going to plug in those numbers. And then radius, of course, is r. So we just got to plug this stuff in. X minus, so h is -3. So if you put -3 here, that double negative really just changes this to a plus sign. Plus y minus, k is 2, equals r squared. So if r is 4, r squared has to be 16. So we would do 4 to the 2nd power. So this right here is the equation. Okay, next one. Circle G has a diameter with endpoints at -4, 7, and 5, 1. Find the center. So this is just midpoint formula. This is pretty simple to find. But what this is essentially saying is you have a circle. And then, of course, that circle has a center right in the middle. A diameter would be going through that center point. So if that diameter has endpoints at, so the first one is at -4, 7. This would be our -4, 7. And then the other endpoint is at 5, 1. If I want to find the center, I just need to find halfway between those 2 points. Okay, so first you look at the halfway point between the x's. So -4 plus 5 and then divide by 2, comma. Do the same thing with the y values. 7 plus 1 and then divide by 2. So when I do the math here, this is going to get me a decimal, which is okay. I think the one on the test is going to be a decimal too. This gives me 0.5, comma, 4. Okay, and then this last one. Circle M has a center at 9, -2, and a point on the circle at 12, -6. Find the radius and diameter. So they want us to find both. So again, if you're trying to picture this in your head, here's a circle. The center, that's at 12, -6. So I'm getting that from, oh, I'm sorry, I looked at the wrong point. This one right here is the center, 9, -2. Then there is a point on the circle, so I'm just going to do right here, at 12, -6. Find the radius and diameter. So radius is going to be the easier one because that's the exact definition of what radius is, to go from center to edge. So let's find our distance formula between those two. So I'm going to label this as r. We first subtract the x's. So here are my x values. I'm going to do 12 minus 9 squared plus. Then we subtract our y values. So -6 minus -2. But instead of doing double negative, I'm going to rewrite that as a plus. Then let's just put this whole thing into the calculator. So give me a second to type that in. Okay, and I actually get just 5. So radius is 5. Okay, and then now I want diameter. So what we know about diameter is that it goes all the way through. And if it's 2 radiuses put together, diameter is just 2 times the radius. So if I fill this in, 2 times 5, that gives me that the diameter is 10. Okay, so I just want to give you a little bit of warning on your test on Friday. I believe the question is going to ask you for diameter, so make sure that you are reading your questions carefully. Okay, so that is all of the practice questions. So now try all of the other side, all the evens on your own. I'm going to make a Schoology assignment where you can type in your answers just to check to see if you got everything right.